we're continuing on in lesson 4.9, where we're now going to look at perpendicular lines. Can you give me, just like some kind of a definition of what perpendicular lines are? We have lines that are perpendicular. That means they're going to intersect. They're going to cross each other. So does that mean any set of intersecting lines are perpendicular lines? There's actually one more requirement. Not only do they intersect, but what? Perpendicular. Central Avenue out here runs perpendicular to 5th Street. So Central Avenue is running perpendicular to 5th Street. What's true about that intersection? Pardon?
They only cross once.
Yeah, they can't really they only intersect once at that location, yes.
There's a right angle.
There's right angles, yeah. Where the lines cross, where they intersect, they need to form right angles. Okay? So we can't have an X that looks like this and the angles that are formed by the intersecting lines. So if we have intersecting lines like this, is what I'm showing, like that, those aren't necessarily perpendicular unless those are right angles in all these spots here. If all of those are right angles, then we would say they're perpendicular. Okay? So these are not perpendicular. And so we have to say perpendicular lines means we have intersecting lines. Intersecting lines where they intersect, they form right angles. Okay. Non-vertical lines are perpendicular if and only if. Here's the good news. There's not near as much work to show today to prove them perpendicular, because how you'll know they're perpendicular is if their slopes, the product of their slopes, what's product mean happens to get a product? Multiplication. So when you multiply the slopes of the lines, their product better be -1. If it is -1, you know that these lines would be perpendicular on a graph. And then vertical lines, what would they be perpendicular to? Pardon? So remember, they have to form right angles. So what kind of a line, Alexis, would form a right angle with a vertical? A horizontal line. So horizontal lines and vertical lines would be perpendicular to each other. So if you can prove that one is a horizontal line and one is a vertical line, then you know that they would be perpendicular. Notice, we don't even care about their y-intercepts. They can have the same y-intercept. In other words, they could be crossing on the y-axis at the same spot. They could share the same y-intercept, but they don't have to. So we are going to not worry about the y-intercept today. We only have to worry about the slopes. So let's just talk about reciprocals, because that's kind of what helps us do this. What's a reciprocal, or give me an example of some reciprocals. Trevor? Yeah, if we have the number 1/2, its reciprocal is 2/1. So what happens when you multiply 1/2 times 2/1? What do we get? What's 1/2 times 2/1? Okay, so the product of a number and its reciprocal is 1. So that does not mean, though, then that the slopes can be reciprocals of each other, because remember, the product has to be -1. So how are we going to get it to be a -1? We're going to take the product of when we talk about the product of the number and the opposite of its reciprocal, now when we multiply those guys together, a number and the opposite of its reciprocal, then we would get -1. So here's an example of some reciprocals right here. 1/4 times 4/1 is 1. But that's just reciprocal. Over here, if we want to get a -1 as our product, we have to take 1/4 times its reciprocal and make that reciprocal its opposite. So, because when we take a positive times a negative, we get a negative. And 1 times 4 upstairs is 4. 4 times 1 downstairs is 4. And 4/4 simplifies to 1, doesn't it? So we end up with our product of a -1. So that means the slopes have to be reciprocals of each other. One has to be positive, the other has to be negative. Okay? So, we only have to worry about their slopes. And if they're a vertical line or a horizontal line, we're not going to worry about their slopes because here's the deal. A horizontal line has a slope of what? 0. What's the slope of a vertical line? Undefined. You think there's any way you're going to multiply 0 times undefined to get -1? No. So we can't talk about the product of their slopes. We just talk about, you know what, if it's a vertical line and the other one's a horizontal line, they have to be perpendicular. Okay, so here we are practicing like you're going to do in your homework today. Number 5 on page 297. Here are the 4 equations they give us, and they want us to pick out if any of them are perpendicular lines. So, remember, we only have to worry about their slope. Are all of those, let's just talk about these first 2. Are they in a form where we can just pick the slope out right now? Yeah. The first one's in slope-intercept form. Y equals mx plus b form, so it's easy to pull out the m. The second one is in what kind of form? Slope-intercept form. It's going to be easy to pick out the m, -3/2. Let's just, you know what, it's kind of looking like maybe those 2 are perpendicular. Let's check it out. Come over here and say, is -2/3 times is positive 2/3, first one's slope times -3/2, would that equal -1? Well, is 2/3 the reciprocal of 3/2?
Yes.
One is positive, the other one is negative. What happens when you multiply by a negative? You get a negative, so it is -1. The reciprocal times its the reciprocals of each other, they have to have opposite signs. One has to be positive, the other has to be negative. So we could go down here right now and say that y equals 2/3 x, subtract 4, and y equals -3/2 x plus 2. Those 2 are, and I'm going to give you the mathematical abbreviation for perpendicular so that you don't have to write that long word, upside down capital T. Now we're going to go check that out on those graphing calculators. Pardon? Are
End of the sentence.
right here?
Yes.
Are perpendicular. This is the abbreviation for perpendicular mathematically. Okay, go to your graphing calculators, turn them on, and go to y equals. Clear out anything that's in there right now, please. And let's type in our first one, y equals 2/3 x minus 4. Remember, we don't have to do the y equals part. How do we do fractions? In parentheses. So parenthesis, 2 divided by 3 parentheses. So you always make your fractions in parentheses. And then your x goes after that. So 2/3 x, subtract, use your subtraction key, 4. And now go and put in the other one. Negative. So negative sign is where? Y equals down by the enter key in parentheses. Negative, parenthesis, 3 divided by 2. So you're going to put in parenthesis 2 divided by 3. Parenthesis x minus 4. Now we're doing the next one, y sub 2. Negative sign down there. And then parentheses, 3 divided by 2. Close your parenthesis, x, and then plus 2. Okay, now I want you to do a zoom 5. Zoom 5. Because this is a rectangular window, we need a square window to be able to tell if the lines are perpendicular or not. If you turn your calculator so that you can kind of see it a little bit easier, do they look like they're crossing and making right angles? Okay. So the graphing calculator kind of verifies that they're perpendicular.
Yes.
Okay. So go ahead and just set that aside for a moment. Let's look at the other 2 equations that we have here. Y equals -1. That doesn't have any x's in it. And I told you a while ago, if it doesn't have x's in it, you're going to know right away that it's what kind of line? Horizontal. If it does not have any x's, you know it's a horizontal line. y equals a number is a horizontal line. Well, when we have just an x, no y, what kind of a line do we have? Vertical. So the vertical line, the equation will always be missing the y part. We'll just have x equals a number. And what did we do? So that's our verification that we are saying. Instead of having to identify their slopes, because we can't multiply their slopes, this one has a slope of 0, the y equals -1, and the x equals 3 has an undefined slope. We can't multiply those. But our definition up above said they will be perpendicular because one is horizontal, the other is vertical. So we know those two will be perpendicular also. Y equals -1 and x equals 3 are perpendicular. Okay, you can't put that one in our graphing calculators though, because you can't put a vertical line in these graphing calculators. Anybody have any questions on this? Let's look at number 6 then. We have those 4 equations. Do we have to do any work to get them ready to pull out the slope? Any of them? What form is the first one in? Slope-intercept form. How about the next one? The rest of them are actually all in what form? Point slope form. Can we already pull the slope out of that too? Yeah. And do we need to worry about the y-intercept today? So we do not need to put these in slope-intercept form today because we don't need the y-intercept. We just need the slope. So we can go right to identifying our slope for all of them. This is the work we need to show. What's the slope of the first one? -3/7. How about the second one? -7. How do you feel about those? Do you think even right now at all that it's possible those two are perpendicular? How would we know that they are not? For sure, they're both negative. They have to have opposite signs, don't they? One has to be positive and the other has to be negative. These are both negative. We already know those two aren't perpendicular. How about the next one's slope? What's the next one's slope? 1/7. Well, there's a possibility. It's a positive to put with one of those negatives. How about the last one? 7/3. Okay. Now what you do is you decide which of those, can I pick out 2 of them and I think that they are reciprocals of each other. So, does this -3/7, is that, don't we worry about the negative right now. What's the reciprocal of 3/7? Okay, we got this one down here that is 7/3, so let's just write it out so we can see that very clearly, because if sometimes you get tricked, you think, well, they're reciprocals of each other, and then you don't pay attention to that they're both the same sign. When you write them down, you can see that they are reciprocals, and one is negative, the other is positive, so yes, we would get a -1. So before we try to see if there are any others, we're just going to write down that that was the first one and the last one. So y equals -3/7 minus 4, and y minus 7 equals 7/3 times x minus 3 are perpendicular. Okay, do you think any others are, or is that the only pair? The other two, the middle ones then. So we would have -7 times 1/7. How do we make -7 into a fraction? Put 1 under it, okay? So now, our 7/1 and 1/7, are they reciprocals, first of all? And one's a negative, the other one's a positive. So would we get -1 when we multiply? So we can say that those middle two are. So y subtract 4, that one. And the y subtract, that starts with y subtract 1. Now, these we can't put in our graphic book. We could if we wanted to work harder. But we can't really check these out unless we put those other 3 in the slope-intercept form, because that's the only way you can put them into the graphing calculator. Well, we don't wanna work that hard, right? So, we're just gonna trust that we know what we're doing now, and these are perpendicular. So, anyone have any questions about how do you support your answers for the work on this next assignment, which is due on Monday, to get this down? This would be the time to ask. So, do you get to just look at the equations, does it look like, and say, okay, I think the first two are perpendicular, and you just write it down, like right here? You get to just do that? Yeah, you gotta show this, you gotta show what the slopes are, and you gotta show that. And then you can say they are, that's your support. Okay, let's go to the back side. Our other learning goal today is I can write an equation to describe a line. So this is just like yesterday, but now instead of the new line being parallel to the given line, we're going to have a perpendicular one. And it's got to go through a certain point again. So I want you to turn on your graphing calculators again. They powered out. And I want you to clear out whatever's in y equals now. And I want everybody to do this. Whatever is in y equals, get it out of there. And I want you to put in y sub 1 what? What do you suppose I want you to put in? The given line. What is it? X minus 6. So I want you to put the given line's equation in your y sub 1. Everybody's going to show me this one, so you make sure you're doing it, okay? When we're all done with this problem, you're going to show me that you actually did everything. Okay, tell me, now go ahead and just press graph for this one. Use the graph key. Tell me what's the behavior of this line. Rising, okay, on your papers, would you just show that the given line looks like this? It's rising from left to right on the graph. Okay, now what I want you to do is I want you to check out that point, like visualize on your graph. Do you think -1, order pair -1, 2, is it on the line? Is it above the line, below the line? Look on your graph. Where does it appear this ordered pair that's got to be on the new line? Where's that at in relationship to our given line? Is it above it? Okay, so let's draw that. So it's somewhere above it, right? That. So what we're really looking for then is not the line that's parallel going through that today, not the one that goes parallel to it, but instead we are looking for the one that is going to go through that point and form perpendicular lines. So we are looking for the equation of this line. Well, tell me right now, what do you know for sure that line has to have? Has to have a 90-degree, well, that line's going to form a 90-degree angle there. It has to do that. Has to have a negative slope because it's falling from left to right. Has to go through -1, 2. Okay, so we got our work cut out for us. Let's go back and make it happen then. So you can just set your calculator aside for a moment. We'll use it again when we finish this. What is the slope of our given line? Because that's kind of important. What is it? 1. Okay. Just wasn't sure what I heard. Therefore, the slope of this line is 1. The new line? What's the reciprocal of 1? What's the reciprocal of 1? 1. 1 is the only number that's its own reciprocal. And then what's the opposite of 1? -1. So the slope of that one has to be -1. Okay? Well, we know it also has to go through that point. So remember, this is where we now put it in our point slope form. So we can get our equation for that line. So we have y subtract. What are we going to subtract from our y? 2. What are we putting in for our slope? -1. What are we putting in for our x sub 1? I'm going to do -1 because I'm doing the actual subtraction right now. So I'm going to, just, but if you can jump right to that, that's totally fine. Okay, that's just our substitution step. Then I'm going to do, like I heard Mitchell say, I'm going to get that cleaned up and make it x plus 1 before I try my distributive property. Because next would be our distributive property. So go ahead and finish this off. Totally confident you can do that. Y equals negative 1x plus 1, is that what you did? Okay, but are we going to see it in an answer bank like that? In other words, can that be cleaned up? What would that look like in an answer bank?
Y equals negative x plus 1.
Yeah, that would look like y equals negative x plus 1. There's the equation of our own. Okay, now we'll put that one in your y sub 2. So we still have our x minus 6 and y sub 1, the given line. Let's put what we think is the equation of the new line in. So again, everybody's going to show me their lines. So when you have it in and you've done the zoom 5, so that it'll give you a good graph. Hold your calculator up for me to see it. Okay, thank you. Okay, do you remember from yesterday how we checked to see if that point that it has to go through is in there? Okay, so those of you who have shown me your graph, you did do a zoom 5, I don't think. Anybody remember then how we find out if the point that it's supposed to go through is on that line? Remember that from yesterday? We go to a table, second graph, that's where the table command is, second graph. And then in the table, you're going to look for where x is equal to what? What's the x value of our point that has to be on it? Negative 1. So go find in the table where x is equal to negative 1. And then over in the y sub 2 column, because that's our new line that it's supposed to be going through, is the y value what? 2. Is that what it's supposed to be? Yeah, so that point that it's supposed to go through, we have verified that it's going through there. And we got a picture of our graph, and they look like they were perpendicular lines, so we can feel pretty confident we have a good equation for our new line. So we're basically saying that this line right here is y equals negative x plus 1. And remember what we said, it should have a negative slope, which it has. So feeling pretty good about this. Remember, this is our given line right here. Y equals x minus 6. Kind of got hidden there underneath my bar. Okay, questions on that one? Okay, the good news about that one, go ahead, Nick.
So like say the first slope was positive 1, the second slope, do you have to just do the opposite?
When it's a positive 1, yes. So if the first slope was a negative 1, what would the other one slope be?
Positive 1.
Positive 1. So that's the one where they're just opposites of each other because 1 is the only number that is its own reciprocal. Okay? Anybody else? What was so easy about that one, getting the slope from the given line? Why did we didn't have to do much of anything there? It was in slope intercept form, so we could just pull it out, couldn't we? And then we just made the decision, oh, okay, here's what the other one's slope has to be. How about number 39 here? Yeah, we have to give it a slope intercept form. It's not in point slope form, we can pull it out, or slope intercept form is a standard form. So we need to get this put in slope intercept form because that's the one that'll be easiest to do with this. We don't have any points to work with this one. So we're going to get the y alone, which again I said this is going to be a skill you're going to do over and over. So get this mastered, get this figured out if you're not very good at it yet. So we have to work harder this time with the given line before we can start on the new line. What's the slope of our given line? 5. So what does that mean the slope of our new line is? 5? Negative 5? Really? Huh.
I mean, wait.
Okay, let's do this.
-1/5.
The opposite, let's write this in our notes, the opposite reciprocal of 5, the opposite reciprocal of 5, well, first of all, is 5 the reciprocal of 5? What is? 1/5. And the opposite of 1/5 is negative 1/5. Now, hear me on this, because you're always gonna think that the new slope is gonna be negative. No. If this had turned out to be a negative 5 slope, then this would have been a positive 1/5, wouldn't it have? So we have to be careful. We have to say, okay, first of all, just look at the number part without its sign and say, what is your reciprocal? And then if that one is negative, the new one will be positive. If it's positive, the other one will be negative. So now we're going to say, okay, well that then is what we need up here. M equals negative 1/5. The new line that has to go through point ordered pair 4, -3, has to have that slope. So we're going to y subtract what? -3. Again, I'm going to caution many of us in here to do this. Some of you are fine and you get away with it. Others of us, not yet. I would clean this up first of all. And then before I did my distributive property on that other side, especially if you keep finding you get these wrong, change that subtraction in that parentheses to add the opposite before you do your multiplying by a negative number. Now you're ready to distribute and hopefully it'll go better, right? So we have y plus 3 equals -1/5 x plus, what's a negative first of all times a negative? Positive. Anybody know what 1/5 times 4 is? Or in other words, if you have 1/5 4 times? 4/5, yeah. And now what do we have to do? Subtract 3 from both sides. And the -1/5 x isn't affected by that. How about the, can't make a plus sign there. Oh, it's kind of looking like I have a negative going on there right now, and I don't in that part. Okay. What's 4/5 take away 3? Anybody know without your calculators? -2 and 1/5. 4/5 is a fifth away from 1, and then 3 is 2 units away from, and this has to be negative. But of course, cleaned up in an answer bank, we would see it not with that plus sign in there, but instead just subtract 2 and 1/5. We're not going to take time to draft this one on the graphic calculator. We're going to trust we know what we're doing. Okay? So, anybody have any questions or concerns or not clear on what the expectation is for these problems? Okay, you can return your graphic calculators to the suitcase and then you can get to work on your homework due for Monday.